planet Mars has a radius of about 3,400 kilometers. If x and y are measured in thousands of kilometers, then an equation for the planet's surface is x squared plus y squared equals 3.4 squared. The center of Mars is at the origin. What function or equations can be used to view this entire circle in a graphing calculator? Why can I not put that equation right into my graphing calculator? It's not a function, right? It's not a function. So we have to kind of trick the calculator into graphing it for us. So how are we going to, what do we have to put our equation in? Where do we put it in? Oh, like y equals? Okay, so how do I get just y? How do I solve for just y by itself? Subtract x squared from both sides. If I subtract x squared from both sides, here and here, I get y squared equals 3.4 squared minus x squared. Correct? So how do I solve for y? Square root. If I square root both sides, I get that, right? No? Okay. Tell me what I actually get then. Tell me, what's the square root of 9? 3. What's the square root of 25? Okay, what if I told you both times you were wrong? Yeah, so tell me again, what is the square root of 9? Plus or minus 3, right? What's the square root of 25? Plus or minus 5. So what is the square root of this side? Plus or minus the square root of 3.4 squared minus x squared. Okay? Understand how many equations are right here? 2 equations, right? There's one equation that says y equals the square root of 3.4 squared minus x squared. And one equation says y equals negative square root of 3.4 squared minus x squared. Okay? Any questions about that? Okay, let's go ahead and do that in the calculator. I'm going to start a new document that is a calculator page. A graph page, excuse me. So I already have my entry line, right? So I need the square root of 3.4 squared minus x squared. What did it graph for me? Half the circle, right? So in order to get the other half, I'm going to press tab, and this time I need the negative square root, okay, of 3.4 squared minus x squared. Hey, look, I graphed a circle. I'm amazing. Now it tells us it wants us to use this window, so we need to adjust our window so that we can see what they need us to see later on. Okay, remember menu, window, window settings. We need to go from negative 14 tab to positive 14 tab. I need to go from negative 9 to positive 9. Okay, now that didn't change a whole lot, but it did change a little bit the size of the window, and we're going to be able to see stuff hopefully in just a moment. Do you have yours? Yes? Okay. At the point negative 8p in quadrant 2, a Martian spacecraft enters a counterclockwise elliptical orbit given by this equation. What shape is this equation? I heard circle and I heard ellipse. Which one is it? How do you know it's an ellipse? Coefficients are different. Also, it says, right? Ellipse. Okay, but that's okay. I'm glad you can look at, because you know that there's going to be some on your test like this. Yes. Okay. What functions or equations can be used to view the entire ellipse in a graphing calculator? How is that any different than the problem before it? It's not, is it? Okay. We still have to solve for y, don't we? Now, it's a little bit more involved. Does that make it harder? No. Let's subtract 3x squared from both sides. And at the same time, can we subtract 24x from both sides? You okay with that? So what we end up with is 4y squared equals 144 minus 3x squared minus 24x. Now what? Divide everything by 4, right? Divide everything by 4. Y equals, oh, thank you very much. Y squared equals 144 divided by 4. I think it's 36, isn't it? 36. 3 divided by 4. 3 over 4, x squared. 24 divided by 4. 6. Why did I write 8? Yeah, I don't know either. Okay. Any questions? So how do I find y? Square root. And when I square root both sides, I get plus or minus the square root of. So here's a good question. Does it matter what order these things are in? Are you sure? As long as the signs are correct, at this point in time, it does not matter what order these are in, does it? But I just get 36 minus 3/4 x squared minus 6x, correct? Excuse me. Use one of these functions to determine the value of p when x equals negative 8. First of all, which one do you want to use? You want to graph it first? Okay, that's fine with me. Whoa, what the heck? On. So we need a tab. Square root of 36 minus... Hey, can I do this? Is that okay? See what I put? I put 0.75, and this says 3/4. Oh, that's fine. They're the same? Okay, good. Tab negative square root 36 minus 0.75x squared minus 6x. Okay, so do we have the whole shape? Now this says use one of the functions to determine the value of p when x equals negative 8. How do we want to do that? How many ways are there to do that? At least 2, right? Maybe more, but at least 2. What's one way we can do it? We can write this equation, but instead of writing x, we can write negative 8. What's another way we can do it? Yeah, let's look at the table, right? Control T. We're looking at equation 3 or 4, right? Control T when x is negative 8. Oh, negative 8. Other way. So one says 6 and one says negative 6, right? Six and what? Mine says 6 and negative 6. You got the same thing? Anybody else get the same thing as me? Or the same thing as she did? We need to make sure we know which one's right. Okay. Samantha, I think these are the right answers right here, 6 and negative 6. Okay? So, guys, if we're talking about quadrant 2, which one of these is quadrant 2 up here? Here's 1, right? Where's 2? On the left side. This is quadrant 2. And it tells us that we're talking about in quadrant 2, right? So, which one is it? It's negative 8. It would be positive 6, right? So, negative 8, 6. How did we do it? We used the calculator. So when I'm studying tonight for my test, I know where I got that answer. Right? Okay. Will the spacecraft touch down on the surface of Mars? Aaron says no. Is he just being disrespectful again? No. Look at this graph, Control T, and tell me if the spacecraft is ever going to touch down on the planet. We graphed it so we can see it, right? Tell me why you think it doesn't. It never touches the planet, does it? Okay? Aaron, you were absolutely right. Okay? So what are we going to write? No, because the ellipse and circle never intersect. Very, very good. Okay, so now we're not talking about the meteor, about the spacecraft anymore. We're talking about a meteor. Dun dun dun. From the point 13M in quadrant 1, a meteor approaches Mars on a counterclockwise parabolic path given the equation y squared minus 2x equals 10. What function or equations can be used to show the entire parabola in a graphing calculator? Wow, that seems like exactly the same question as this and exactly the same question as that. Oh, that's because it is, right? What do we have to do? Solve for y. Y squared equals, because I added 2x to both sides, right? So 10 plus 2x. What do I do to solve for y? Square root both sides. Excellent. Y equals plus or minus the square root of 10 plus 2x. Want to go ahead and graph that? On tab. Whoa, what the heck? I don't think I do. There, okay. Tab. Y equals the square root of 10 plus 2x, right? So that's the top of mine. Tab. Y equals negative the square root. What did I say that for? You know what I mean. 10 plus 2x. Okay, now, I have a problem with this graph. Do you know what my problem is? Anybody? I can't see anything. All these labels and stuff are in the way. Don't boss me, I'm moving them already. Rude. Well, you better shut up, Aaron. That was not yelling. You should. Sierra did.
Yeah. That was funny. Really? Yeah, really.
I don't know why you're pulling me into this. Okay, is that a little bit better? A little bit easier to see? Okay. Use one of these functions to determine the value of m. So when x equals 13. What do you want to do? What? Oh, on the table. Okay. Control T. Which one are we looking for? We're looking at 4 or 5, right? F of 4 or F of 5. And we're looking for x is 13. Oh, excuse me. Thank you. F of 5 or F of 6. I either have 6 or negative 6. Right? 6 or negative 6? Which one is it? What quadrant are we in? We're in quadrant 1, so I've got to go 13 and 6. 13, 6, and again, I figured that out by using the calculator, correct? Will the meteor hit the surface of Mars? If so, where? If not, explain. Yes, where? Where will it hit? You said yes, so I'm asking you where will it hit?
That's part of my question.
Oh, okay.
Where those intersections count?
That's a very good question. He says, do all 4 of these intersections count? Traditionally, in a math problem that I give you, and here's 2 systems and find where they cross, the answer is yes. In this situation, we're talking about a meteor and a planet. Is the meteor going to hit the planet and travel through the planet and out the planet and come back and hit the planet again and travel through the planet and back out the planet?
That'd be one awesome meeting.
That would be a really cool meteor, but no, right? Which one are we concerned about? What do you mean the very first one? Well, we have to kind of know the direction the meteor was traveling, right? And we know because of this drawing and because it's talking about quadrant 1 here in the directions that it's coming from quadrant 1 heading toward the planet. So the first time it could intersect with the planet is right there. Right there. Does that make sense? So we need to menu. What do you think? Analyze the intersection of that part and that part. And then remember, it's going to ask us left and right bound. You remember that? Lower bound, so I need to put it on the left side of that intersection. So like maybe right there, and click it. And then need to move it on the right side of that intersection. It's thinking a lot. Must be a girl calculator I'm using today. So I'm having a hard time seeing that intersection, so I'm going to pull it over here a little bit so I can read it a little easier. So I got 0.6 and 3.35. Is that what you got? So 0.6 and 3.35. What does that mean? Okay, so how am I going to answer this question? Yes, the meteor will collide, okay, with Mars at probably approximately, right? 0.6, 3.35 on the graph. Yes? Questions? So how many conics have we dealt with so far? Which one was the first one? This was a circle. This was ellipse, parabola. So what are we missing? Hyperbola. So guess what? We're not going to do that. Just so you know. Okay? Items 2b and 3b from the previous page involve using x values to find corresponding y values on conic sections. Show how this can be done without a calculator's graphing capabilities. Oh man. I really don't hate you. Not out loud. Not out loud. Okay, so how do you want to do this? 2b and 3b. 2b was find the value of p when x equals -8. So I use this equation, right? Do I have to use this one or can I use the original one, like that one? Probably use the original, right?